Hi, everybody, and welcome to the webinar, Getting Started with Kotlin Multiplatform, Building Applications for iOS and Android with Shared Logic and Native User Interfaces. So my name's Garth Gilmour, and I'm a developer advocate at JetBrains. Pamela, do you want to introduce yourself?
Sure. I'm Pamela Hill. I'm a developer at JetBrains as well.
Cool. So I'll be walking you through the first part of the webinar, and then I'll hand over to Pamela. So this is the second of 4 webinars on Kotlin Multiplatform. The first one was a detailed review of everything that's new and shiny and interesting in KMP, so giving you the big, broad picture. In this webinar, we're just going to be drilling deeply into one particular use case. So good news, Kotlin Multiplatform is stable. So everything we're going to be discussing for this particular use case is production ready. You can go out and try it and deploy it. It's all good. But nothing ever stands still. There's lots of new and interesting toys coming down the pipe as well. So for more information about those, see the previous webinar, but also see the document referred to here on the right, the multi-platform development roadmap for 2024. So more new and interesting toys and shiny things on the way. So what are we going to be covering in this webinar? Well, we're going to be building the webinar around one particular use case, and it's this application here. So what we've got is an application written in both Android and iOS. And as you can see, what it does is it displays a list of countries alphabetically, but with your current locale at the top. So you can scroll through the countries, and you can click on one of the capital cities, because some countries have more than one capital city. That's a complication that we have to work around. And whenever you click on that capital city, you get to see the weather, and then you can go back. So the way that this works is everything underneath the user interface is Kotlin Multiplatform. So the code for representing the domain types, the code for doing the business logic, the code for caching, networking, all that kind of thing, that's done in Kotlin Multiplatform, but we're using a native UI. So in the Android version of the application, it's Jetpack Compose. In the iOS version of the application, it's Swift UI. So we're mixing Kotlin Multiplatform with a native UI. So before we dive in, there's no need to take detailed notes at all. You have access to all the resources. So this webinar is being recorded. So if you're watching it after the fact in the gym, you can speed it up to 1.5. If you're having problems with my Belfast accent, then I apologize sincerely for that. And you might need to watch it at 0.5. Okay, so you will have access to the recording, and all the sample code for the application is in this repo here. So there's the full GitHub link and the shortcut, and I think one of our colleagues is going to be putting it into the comments as well. So you'll be able to access that. And the slides are included within the project in the docs folder as a PDF. So everything you need to follow along with what we're doing and then try it yourself afterwards, it's all provided to you. So what questions are we going to answer? First of all, just the essential theory to make sense of the project layout that we're going to show you and the code that we'll be demonstrating and so on. So enough theory to understand everything that follows. So what at the end of the day is Kotlin Multiplatform KMP? And then the standard questions that you need answered whenever you get started with any kind of development. So first of all, how do you set up your machine? How do you prepare your machine for Kotlin Multiplatform? Having done that, how do you create a project? And then having created the project, where do you add the different bits of code? You know, so where do you put your model types, your business logic, your networking code, especially in this case, given that we're using a native user interface, where do the different components there go? And then how do you start things running? So we're going to run on the Android emulator and the iPhone simulator. And then because this is multi-platform development, we've got one extra thing that we need to tackle, which is how do we perform platform-specific tasks? So let's say we need to get information about the current location, or we need to find out information about the current device, or we need to get a path to a file or something like that. So we're going to need to do that on all targeted platforms, but the way that we're going to implement that will vary from one platform to another. So for multi-platform development, any kind of multi-platform development, this is another problem that we need to solve. So how do we perform platform-specific tasks? So first things first, what is Kotlin Multiplatform, aka KMP? Well, see the previous webinar. Okay, so as I say, the previous webinar gave a really detailed review of all of this information. Really encourage you to go check it out. But for the purposes of this webinar, there's one thing we'd really like you to know, and that's multi-platform means sharing. So whenever you're doing multi-platform development, you have what we call common code, and this is just regular Kotlin code that you're going to build and deploy on 2 or more of the platforms listed below. So that's what makes it multi-platform development at the end of the day. So in a little bit more detail, you're going to have a shared module, as it's called, and in there you're going to have your common Kotlin code, and then it's going to get built in different ways. So in our demo application, we're targeting iOS, so our Kotlin code is going to be compiled by the Kotlin native compiler. That'll give you a framework file that you can use in your iOS app. But we're also deploying to Android, so we're going to use the Kotlin JVM compiler, and that will produce a jar file that we can then use in our Android app. So the same code being built different ways for different targeted platforms. So these are the 2 platforms we're targeting here. You could be targeting different ones, more ones, it's all good. So what's the scenario for sharing code? Well, first of all, let's say you've got some services. So on the server, you've got some services that you've written in maybe Ktor or HTTP for K or Spring or something like that. And you've got your domain types and maybe some conversion, validation logic, all this kind of stuff. And you want to share that with the client. And maybe the client is written in Android, maybe the client is written in iOS, maybe it's running on the desktop. You know, it's all good, but you want to do the sharing between the clients and the server. Or maybe you just want to share across the client. So the same kind of code that I've just mentioned, maybe you're going to be sharing that across Android and iOS. Maybe you're going to be sharing it across Android, iOS, and desktop. But at the end of the day, it's all about sharing. So a slightly more detailed question leading on from that then. So precisely what are we sharing? And this is one of the big advantages of Kotlin Multiplatform over similar frameworks, which is that it's not binary, it's not a zero-sum choice, it's not all or nothing. You can go out and decide how much you actually want to share. So let's say that before you even considered multi-platform development, you had 3 clients. So you had an Android client, an iOS client, and a desktop client. And these were completely separate code bases, but you had the same 4 layers of architecture. So of course, you've got the user interface layer, and then below that, you've got a presentation layer. So inside there, there's your code for conversion, validation, navigating between views, that kind of thing. Beneath that, you've got your business logic layer with your domain types and so on. And then conceptually at the bottom, you've got the code for talking to data stores and doing networking, that kind of thing, maybe going out and accessing some RESTful services. So as I say, in the very beginning, let's say we have 3 clients, with 3 different technology stacks. So the first thing that you might do with Kotlin Multiplatform is just share that business domain layer, and maybe not even the entire layer, maybe just a small subsection of that. So I'm a huge fan of DDD. I take domain-driven design really seriously. So let's say you've gone out and built a shared kernel, and this contains the essential types that you want to expose across all the different clients and versions of the application and so on. So maybe it's just your shared kernel that you're sharing out with Kotlin Multiplatform. All good, but then maybe you decide, okay, we'll share that layer and we'll share the data core layer. So we're also sharing the code to access the data store and talk to our RESTful services and so on. And then maybe you might take it one stage further and say, okay, we'll also share the conversion, the validation, the navigation code. Now, obviously, we're showing a progression here, but that doesn't mean that more is necessarily better. It all comes down to your own particular scenario, whatever that happens to be. So maybe it makes sense to share all these 3 layers. Maybe it makes sense just to share half of one layer. But you can do all of these different options with Kotlin Multiplatform. As I say, that's one of its strengths. So who's doing it? Well, here's a little graphic of people going out and using Kotlin Multiplatform in production right now. For all of these slides, the link is always at the bottom right. So if you were to follow that link, you can go, in this case, to the JetBrains website, and you can get detailed information. I think Forbes there are the one who were most recently in the news. They were in the news anyway, just as we were putting these slides together, for taking their main application and moving it to Kotlin Multiplatform, using much the same use case that we're discussing here, but there's hundreds of other companies that you could talk about. So happy days. Let's get started. So this is what we're going to be doing. So we have our Android application and our iOS application, and as we've said, we're going to be sticking with a native user interface. So in the case of Android, that's Jetpack Compose. In the case of iOS, that's Swift UI. But then we're going to have a shared module, and inside there we'll have our data core layer, our business domain layer. We did intend to put in a presentation layer, but at the end of the day, our application just responds to clicks. Yeah, so you're just going to be given a list of countries, clicking on capital cities, clicking to go back, and so on. So there isn't really a presentation layer. The tiny bits of presentation logic, they kind of went into the UI layer by default. So we can't claim to that. We can boast about one thing though, which is this multi-platform library section. So that wasn't on any of the previous diagrams. So what's going on there? Well, whenever you start down the road of doing Kotlin multi-platform, multi-platform doesn't mean you have to write all the code yourself. Okay, so there's a huge ecosystem now of Kotlin multi-platform libraries that you can go out and use, and this includes libraries for doing dependency injection, declarative networking clients, entire architectures for your application as a whole, view models that work cross-platform, database access code. It's all there. So this is, well, the clue's in the name. This is an awesome page. Yeah, awesome Kotlin multi-platform. So you can go out and browse the available multi-platform libraries and pick the ones that best work for you. But again, you only have to use the ones you want to. You're not required to use any of these at all, but you would find the mix that works best for your project. So in this case, we wanted to make our life simple, and we wanted to make the application run a little faster, and we wanted to show you a multi-platform library. So we went out and used KStore. So in our application, we're going to be going out to a RESTful service and getting a list of countries. Yeah, and then having retrieved the countries, we'll display the capital city, click on the city, and we'll send another request to get the weather. So what we wanted to do was cache the responses that came back. So we use KStore to do that. So what KStore lets us do is take Kotlin objects and then serialize them as JSON down to the file. So we're going to be using that for our caching. Interesting point. Although it's a multi-platform library and the logic will be the same on all targeted platforms, the location of the file will not be. Okay, so this is one of those tasks that we're going to have to go out and do in a platform-dependent way. So we're going to have to go out and get the path to the file and create the file and so on differently on iOS and Android and any other platforms that we were targeting. So when Pamela's showing you the code later, that will be an important point. Right, so that's all the introduction, that's all the background stuff. Let's get into the nitty-gritty. So how do you set up your machine? So there's detailed information on how to do this on the JetBrains site, but let me give you an overview. So we're targeting Android. Let's say you're targeting Android. You'll want to install Android Studio. And then having done that, you'll want to go inside Android Studio and create a virtual device. So you're going to be emulating an Android phone, let's say, hopefully a fairly recent one so that you get access to all the features. Yeah. And once you've done that, if you're not using Android Studio as your primary IDE, well, then you can ignore it if you want to. So here's a little page from the Android documentation, just showing you how you can go in and create and manage virtual devices. So that's the extra step. You would install Android Studio and then use this virtual device manager to create an emulator, and then you're good to go. So also targeting iOS, yeah. So you're going to go out and install Xcode and then launch it. Slightly more complicated process there because you have to make sure that you accept the license terms and let it finish installation and so on. So just go in and launch it once and make sure that you've taken the installation all the way through, including accepting the legal stuff, and then you'll be good to go. Now, if you have your Mac OS machine set up to do updates, it might automatically get a new version of Xcode, get a new version of the iPhone simulator, and so on, in which case you would need to relaunch Xcode and say yes again to the terms and conditions. So that's something to watch out for, okay? Otherwise, you can ignore it, okay? Question that often comes up, what about CocoaPods? So for those who don't do Swift or Objective-C, it's a dependency manager that you can use. And in Kotlin Multiplatform, you can configure it within your Gradle build file, and it can be used to declare your native dependencies. Yeah. So you can use it or not use it. It's up to you. We don't take a position. Yeah. But whenever we were creating our application, for simplicity's sake, we didn't use it. Okay. So that's our setup. So assuming that you've completed your setup and you want to validate it, on the Mac there's a utility you can run called KDoctor, and this will look at all the potential setup that you need to do for Kotlin Multiplatform and let you know whether it's there or not. Just note that you don't necessarily need a completely clean bill of health. If it says that you don't have something and you're not using it, well then obviously that's not a concern. Okay, so you don't necessarily need absolutely everything to be there to make progress. Right, and then the final thing in terms of setup is to select your IDE. So Android Studio, perfectly good. IntelliJ IDEA, perfectly good. But we would say that you should consider Fleet. So Fleet is the new IDE being developed by JetBrains. It's a polyglot IDE. You can use many different languages. For more information, see the previous webinar. And I used it for a lot of the development that I did for this sample application, just to get familiar with it myself. So good things about Fleet. Well, here, remember, the use case that we're doing is the native UI, okay? So we're going to be writing and editing an awful lot of Swift code. So it's really good to have code completion and refactoring and so on right there, built in the IDE. And then we're going to have Swift code calling Kotlin code. So cross-language navigation and refactoring, very useful, okay? So if I have some Swift code that's calling a Kotlin function, well, I want to be able to navigate to that Kotlin function. And then back in the Swift code, if I do a refactor and a rename, I want that to work. I want the Kotlin function to be renamed in the corresponding Kotlin file. And then we also want cross-language debugging. That would be even better. So again, Swift code calling Kotlin, I want to be able to set a breakpoint and then step in and travel from my Swift code to my Kotlin code. One con though, it's still in public preview, so expect issues. Expect to have to update the thing, expect to discover the odd issue and so on. Yeah. So I adopted a workflow whenever I was doing my own development where I'd be working away and there would be an error and I would say, Fleet, still in public preview, doesn't understand my code. Then I'd open it up in Android Studio and Android Studio wouldn't understand my code either. And then I would discover that the error actually lay in the empty space between my ears. Yeah. So as always, it was all my fault. Yeah. So the lesson there though is that you can switch from Fleet to Android Studio and so on. You can just go backwards and forwards and that's completely fine. Yeah. So trying out Fleet is something we would recommend. Right, so dropping down another level of detail, how do you create the project? Yeah, very simple answer these days. Go to kmp.jetbrains.com and there's a wizard that will do it all for you. Okay, so as with all these wizards, it starts with a name and an ID. The ID is important because that will control the name of the package that gets generated. The interesting bit, though, is when you choose your targeted platforms. Okay, so in our case, we're going to be targeting Android and we're going to be targeting iOS. And we'll hit the little radio button at the bottom there where we're saying do not share the user interface. So we want to have a native user interface on both Android and iOS. If you're interested in the scenario where we're using Compose Multiplatform and sharing it, that's what the next webinar is all about. So all interesting questions about that, we'll defer them to the next webinar. That's not our job here. We could also be targeting the desktop, and we could also target the server. In that case, what would happen would be a KTOR service would be created, and then you could communicate with that KTOR service from any of the clients, and you could share your domain types in the way that we were talking about before. So as I say, you run the wizard, you get the project, open up the wizard in your IDE of choice. So here it is open using Fleet. Yeah. And then you want to make sure that you can understand the structure of the project that's been generated. So what we want to make sure that we're putting the code in the right place so that everything builds properly. So your eye will naturally be drawn to this module called shared. And if I can teach you one thing, about Kotlin Multiplatform, it would be don't make the mistake I did. Okay, so don't think that this shared module only holds code which works on all platforms. Okay, that is not correct. Okay, if you think that, it'll send you off in the wrong direction. Okay, instead, this module is where we develop the code that will be shared across different platforms. Okay, now I am aware that that's a subtle distinction. So let me just dig into that and explain what I mean. So the shared module is a Kotlin multi-platform module. And as you can see from the picture on the right, we've got 3 source sets. So we've got common main, Android main, and iOS main. And which of these source sets get compiled, it depends on which platform we're currently targeting. So let's say we're building for Android. Well, then we'll be compiling common main with Android main. Okay. And let's say we're building for iOS. Well, then we'll be compiling common main with iOS main. So you see that it's always common main. So we're always compiling common main, but then we're compiling it with another source set. And that's the source set that's specific to the platform that we're targeting. So a very logical question now is why? Why would we be doing this? And the answer is for those things that we mentioned earlier, those tasks that we always need to accomplish where the implementation will be platform specific. So examples would be the one I gave earlier. You're using KStore, but you need to get the path to and create and open a file. Or maybe in this case here, we just need to generate a random ID. So it's something that we want to do in common main. So in common main, we're going to have calls to this function here, random UUID, but the implementation will be platform specific. So we declare the function in common main. We declare it, but we use the expect keyword. So this is now an expected declaration. And it's expected because we're expecting an implementation, a definition, whatever you like to call it, in each of the targeted platforms. So in each of the targeted platforms, we need to have a function called random UUID with the actual keyword on it. So now it's an actual declaration. So for every expected declaration in our common Kotlin, we need an actual declaration in each of the targeted platforms. So as you can see on the left, for iOS, we've got one that's using platform.foundation. And then on the right-hand side for Android, we've got one that's using good old Java util. So hopefully that helps make sense of the different source sets that you have. So to summarize, common main contains your common code, and this is the code that is indeed going to be used on the different targeted platforms. So the only dependencies that you'll have in there will be on multi-platform libraries, in our case, KStore, And then in common main, we're also going to have expected declarations, and for each expected declaration, we're going to have a matching actual declaration in each of the platform-specific source sets, okay? So hope that that clarifies what's going on in that shared module. Just before we move on to the other parts of the project structure, a little bit of advice on using expect and actual functions. So a few expected declarations are completely fine. Obviously, a lot of them would be a code smell. It's going to complicate your code because every time you do an expected declaration, you have to make sure there's an actual declaration on each targeted platform. And yes, you will be reminded. The IDE and the compiler will remind you, but you'll have to, keep track of them and so on. So you don't want a lot of these. So the good news is there's a very simple answer, which has practically been always with us in OO theory. And that's use an interface to model the abstraction, and then use your expected functions as factory functions. And if you end up with a lot of interfaces, it may be a good idea to adopt a dependency injection framework. So to use an example, which is from our own generated code, let's say you need to know a lot about the platform that you're currently targeting. Let's start with just the name. So we create an interface called platform, and we have a property called name. And then we'll have an expected declaration, and that's going to act as a factory function. That's going to return some kind of platform implementation. So in Android, we'll have a platform-specific type called Android Platform, which implements the platform interface. We'll have an actual declaration to build and return something that implements the interface. And we'll override the property. And then in iOS, we'll do exactly the same thing. So we'll have a platform-specific type that implements the interface and an actual declaration that, in this case, builds an iOS platform object. And then we'll override the property in the appropriate way for that platform. So again, a little best practice, use interfaces to model the abstractions. And if you're creating a lot of interfaces, that might be a sign that adopting a dependency injection framework would be a good idea. Right, so that's us done with the shared module. Let's move on. So we also have a module called Compose App. And this is a Kotlin module, and it contains a single source set in our particular use case. So remember, our use case is the native UI use case. So on iOS, it's going to be the native framework there that we're using. So here for Android, it's going to be Jetpack Compose. So we're going to have a Jetpack Compose based UI inside the single source set, which is called Android main. If you were doing Compose Multiplatform, there'd be more in there. See the next webinar for details. And in here, as well as having your Jetpack Compose UI, you'll also have the other Android types that you need. So at an absolute minimum, you would need a single activity to launch your UI. In a real application, you're probably going to have a lot more. And then finally, you're going to have your iOS folder. So this is an actual, honest to goodness, Xcode project. So you can actually open this in Xcode and edit the code there if you like. And this is where we're going to put our Swift UI user interface. So this will contain the native user interface and all the code needed to launch the thing and to get it running and so on. So on Swift, you're going to need at least one controller in the same way that you needed one activity on Android. So this is where we're going to be placing our Swift code. Right, so that's it for how you get everything set up. All that remains is the simple, trivial, straightforward task of actually writing the damn thing. Okay, so this is the point where I do Sir Robin, as they say, if you know Monty Python, and I bravely hand everything over to Pamela. So over to you.
Thank you, Garth. Right. So how do I start adding the code? Right. So just a reminder of our application that we were looking at before. So we have on the left-hand side, we have an Android application that's using Jetpack Compose to put all the beautiful UI elements on the screen. And on the right-hand side, we have an iOS device that is using Swift UI to put all the beautiful UI elements on the screen. And we have like a list of countries that are all sort of in alphabetical order, and they have their flags, their common names, their official names, and then a list of buttons of their capital cities. And when you click on the capital city button, it takes you to the weather screen, and it just shows you like what the current weather is like in that capital city. So what do we need to do to get all this stuff together? Firstly, we need some domain types. Then we need some networking code to get the data from the web services. We need to support caching to make things a little bit more optimized. We need to do platform-specific things like creating the cache file. We can't do that in just one specific way for all platforms. It needs to be done in a platform-specific way. And as you might have noticed over here, if I go back, at the top of each list, there is an out of order country. You'll see on the left-hand side, I just showed you United States for Android and United Kingdom for iOS. Why is that? That's because the device's current setting is a specific region, and for the left-hand side, it was the US, and for the right-hand side, it was the UK. So I've fiddled with the device settings, and I've changed the region for that specific simulator or emulator. So we're actually reading the device settings, and we're moving that country way to the top so that we don't have to scroll around to find our own country's settings. So we need to find the location or region of our country, of our device, and then we need to obviously create a user interface. For Android, we're using Jetpack Compose. For iOS, using SwiftUI, and then we somehow have to get all that data that we just got via networking and sort of cached and everything into the user interfaces. So we've got a lot to do, so let's get started. So first we need to work on domain types. And for that, we have two subdomains. We have one to model countries and one to model weather. And you'll notice perhaps some of these data classes that you can see have quite interesting names like EngX and WeatherX, and that is because they come from external APIs that decided that these are great names to give classes and fields. So that is the reason behind those strange names. So after we've actually sort of specified all our data types, we now have to support networking. So our networking code is going to use two servers, restcountries.com for countries, which is an open service, and APIs, openweathermap.org's API for the weather, which requires an API key, but it is free to use. And then we have a client for each one in country API and one for weather API. So in order to actually do the networking, we're going to use some multi-platform libraries to do all the hard work for us. And that is going to be Ktor to send the GET requests to those two servers, and it will return a response with the countries and the weather objects to us. Kotlin serialization for doing marshalling between the JSON data that comes back and Kotlin objects, and KStore to cache the result that we obtain. So it's going to take the Kotlin objects that we have, after we've retrieved them, it will have a list of countries, and they will be Kotlin objects, but then we want to save them into a file, and we will use KStore to do that. So one of the most important files in that shared module or directory that Garth was talking about is called build.gradle.kts. And in there, we can see that we can define some dependencies in the source sets corresponding to, we can define dependencies for each source set. So here we can define dependencies for Common Main, Android Main, and iOS Main. So that just means that we can add libraries to each of these source sets and use those libraries within the source code of those source sets. So for Ktor, we're going to have to do the following. We're going to have to add some dependencies to the common main section. So those are sort of common Kotlin kind of questions. These libraries, they are more multi-platform libraries. So that would be Ktor Client Core and Ktor Client Content Negotiation and Ktor Serialization Context JSON. And then we have to add two platform-specific dependencies, that is Ktor Client Android and Ktor Client Darwin for iOS. So the reason for that is that Ktor needs to do network requests in different ways for different platforms. So when we want to get all the countries for a particular once we sort of launch our application, we want to get all the countries for displaying on the user interface. And so we define a function called getAllCountries that returns a list of countries. And we mark it as a suspend function because it's a network operation, so potentially long running. We then use the Ktor client called HTTP client. We save a HTTP client, Ktor client in there, and then we call the GET request on that URL. We retrieve the body, which is of type list country, and then we sort that list that comes back from the web service according to the common name of that country. Now, what's really, really key to remember here is that you have to use Kotlin serialization to help you with this, because the data that actually comes back is JSON. It's not Kotlin objects. So you have to mark your data class country with @serializable so that Kotlin serialization will be like, I have to take this JSON and convert it to this object. with this a class object of this kind of class. And similarly, when you want to get the weather for a particular place, you have to pass in the latitude and longitude, and you get something of type weather back. Again, it's a suspend function because it's a potentially long-running operation. Then you can call the KTOR client's HTTP client again with the GET request. So it's just the GET method. And you pass in a URL and a query string, and you just retrieve the body. Once again, it's super, super important to mark your data class weather as at serializable, and all the classes that are sort of inside of that tree of dependencies as well. So clouds, chords, WeatherX, wind, and so on. So something interesting that you might have seen here on the screen is query string. So we pass in and we use string interpolation for lat and long, but then we also have this key variable. And what we did here is, because the API actually uses a API key, we've taken that the key that we got from, we registered with their admin console, and we got an API key. Then we saved it into a particular variable in our local.properties file. And then we used a Gradle plugin called build config with a K, and we saved inside that config object a weather API key variable that corresponds to that API key. So that is just like a multi-platform way of getting something from local.properties into a Kotlin object that you can retrieve from your common code. There is, by the way, so somebody from our team has added the repo URL to the comments and chats and so on. And you will be able to find all the code there, but you'll also be able to find the instructions on how to run this application yourself. And I see this question over here that's saying, where can I find this presentation? Yeah, there. Where can I find this presentation? It's in the slides directory on that repo. Okay. So next, what we need to do is to support some caching. So whenever we go from the country screen to the weather screen and back again, we don't want it to reload the countries every time again from the web service. We want to make it nice and quick. So we're going to do some caching here. And for that, we're going to use a library called KStore by Suru Rayapakse. And it basically just saves and restores objects to and from the disk. It's very simple, and it uses Kotlin Coroutines, Kotlin serialization, and OKIO for it, for doing all these things. And this is what we need to do. So we need to add to common main our KStore and KStore file dependencies. And then we create our cache using a builder function called store of, where we pass in a file path. And here we're passing in something, some argument that is path to country code. It's a function invocation. And I'm going to be defining that in a very platform-specific way, and I'll explain to you in just the next section on how to exactly do that. But we need to, we basically just create the cache with the store of function. And then the next thing that we need to do is actually do the logic for caching. So we get the sorted, in order to get the sorted countries, we either, we just get we call cache.get, which will go and read from the disk and see, is there something in this cache already? If there's not, it will try and retrieve the countries from the web service and then place it in the cache. Otherwise, it will just return the cache. And so that's a normal kind of caching mechanism. It's a very, very simple caching mechanism. And this is also done in common main. So the next thing that we need to do is to do platform-specific support. Now, firstly, for the cache file. Now, I promised that I would show you exactly where that's going to happen, and I'm going to show you exactly how to do that now. So for that, for KStore, we actually need a JSON file, and how we do that is platform-specific, where we're going to save it. So we're going to have an expect function in common main, and our actual declarations will be platform specific. So there'll be an Android main and an iOS main. So here we see my promise has come true. Isn't it amazing? We see our expect fun path to country cache that returns something of type string in common main. And then for Android, in Android main, we see that we have our actual function implementation where we just pass back something called file path. Now, file path is a late init var that we actually initialize not in Android main, but in compose app slash something something Android main, where we initialize the application or the Android application. So whenever we start up the application, the onCreate function will be called by the system, and file path will be set to the context files dir path / country cache.json. So that last section is just a made up section name. It's the files dir.path that is where the user that's the user directory path of the Android system. For iOS, things are so much more easy. This is because we can just use ns home directory / country cache.json in order to implement the actual fun path to country cache. Now, I see there's a question that says, doesn't KTOR support HTTP cache? It depends on the API, and the API in this case did not support the HTTP cache. So for platform-specific support, we also need to remember that we want to have the current country at the top of the list. So we have to work with locations and regions of that device. So for that, we need to work with country codes. And the way that we find these is platform-specific. So once again, we're going to use expect and actual. So in common main, we're going to define an interface called country code service that has a function called get country code, and then we're going to have a factory function called expect get country code service that returns that country code service. And then so for Android, we're going to basically implement the country code service with a class, and the get country code is simply locale.get default country. That is a JVM call. Then we just implement our actual function with passing back an instance of that Android country code service. So for iOS, something similar. The only difference is the implementation of get country code is ns locale current locale object for key ns locale current country code, which is quite a mouthful to say, but I'm very proud of myself. I did say it. And we just return in the actual function, we return get country code service, and we return the iOS version of that service. So the sorting logic is a little bit tricky, but it is in terms of just reading it, but it is in terms of just talking you through it. We just get the country code for the particular device. Then we get the sorted country, so everything will be in alphabetical order by the common name. Then we get we try and find our current country that matches the particular country code. We take that current country out and we just put it at the top, and that is the sorting logic for our getting us our sorted countries list. So then we have to finally sort of start creating our user interfaces. So first we have our Jetpack Compose based interface, where we're going to have, you can see there, we are going to develop our Android UI using Jetpack Compose, and it is made up of composable functions. And so these are going to be able to use Android-specific libraries. Here we are in Compose app, so we can use Android-specific libraries like Coil to display images, and I also used AndroidX navigation to navigate between the two screens. And so they have to live in Android main. And so here you can see in the Compose app, the build.gradle.kts file looks like this. It has the coil dependency inside of it in the Android main section. So this is a country composable that we're going to quickly have a look at. So if you're quite used to every with Jetpack Compose, it is pretty easy to understand. So we have a flag composable, we have a country names composable, and we have a weather button composable. So the flag is just like the various flags. The country names is either the common name and the official name, and the weather button is like a list of buttons. So that is just translated kind of loosely into rows and columns with various modifiers. So we have a horizontal structure with rows, and then and in the first sort of cell we have flag, and then in the second sort of column we have the country names and then the weather buttons. And so that is basically how we would develop the Jetpack Compose interface. SwiftUI is a little bit more interesting if you've never seen it before. So once again, we're here in iOS app. We're looking at Swift files, and we're developing with SwiftUI. So we're going to create structures which inherit from Vue, and we then arrange them as a tree. And we use horizontal layouts. So when we want to use a horizontal layout, we use HStack, and when we want to use vertical layouts, we use VStack. And if you want to stack things on top of each other, you can use ZStack. We also use the Kingfisher library to load images. So the type of that image is just KF image. So here we have the view that we're going to be creating with a flag and a VStack with two text views. So this is basically what it looks like. It's a struct called country details view of type view. And there, instead of passing in the state in the composable function like we would with Jetpack Compose, we use the state variable country. And then we have a variable body that is of some view. And then we use our HStack and the various elements to sort of combine these UI elements into like a bigger UI. So we have our HStack with the image, and we use downsampling to make the very large flag a little bit smaller, just so that it fits into the screen nicely in a frame of width 75. And then we have a VStack with two text elements below each other. So to get the data in the interfaces, we need to do the following things. So first we define a list of countries. Then in order to call the suspending function from within Jetpack Compose, we need to use a launched effect side effect. So we call the suspending function and we assign it to that variable that we would have created. Then we use in a lazy column, we can actually use the items indexed way of doing things, and we just give that list of countries to the item as an items parameter. And then we will basically just create the country cards all in one long list. So it will be a lazy column of country cards. For iOS, it's a little bit more interesting. So here what we've got is we for iOS, the difficulty is that you have to do a whole bunch of things, like you have to support cancellation, and you have to make sure that things are still readable. And we will be using a library called KMP Native Coroutines for this. So it's in the general way of using coroutines and suspend functions, you can either use completion handlers or you can use async await, but they do not support cancellation. And so we have to use this wrapper or plugin library called KMP Native Coroutines. And this is something that I'll discuss in the fourth webinar a little bit later in this series. But what we need to do is that we need to have a plugins section in our shared build.gradle.kts, where we have to have KSP in there and KMP Native Coroutines, and we also need to enable we have to opt into a particular experimental language feature for all the source sets, and that is just a requirement of KMP Native Coroutines. And then whenever we have a suspend function that we want to call from Swift, we mark it as @native coroutines, which will generate some code in the background. So here we're marking get all countries with @native coroutines. That's a function from KMP Native Coroutines. And then we get this very interesting piece of code. So what this is it's going to load the countries, and initially the state of the user interface is going to be loading. Then we're going to get all the countries, and we're going to wrap that in a async function over here, and we're going to await the result. And once that result is retrieved, we're going to change the state of that UI to the result state with a long list of countries inside of it. And the way that we do that is with this self.loadable countries, which is just the state that's displayed on the user interface. It's called a published variable. And that is basically it for how we do Swift UI stuff. But the more detail for KMP Native Coroutines and its alternative, which is called Sky, please join us for the iOS Development with Kotlin Multiplatform Tips and Tricks webinar. That's going to be next week, Thursday. And we're going to go into a lot more detail on how to call things from Swift, what some of the sort of more difficulties are, how to get past them, what libraries and tools and techniques you can use, and so on, and how to also get your team involved with your iOS developers and your team excited and wanting to share with you and work with you on this technology. So we've pretty much gone through the whole application is going to work. And with that, we can go on to our conclusions. Back to Garth.
Excellent. Thank you very much indeed. So just make sure, whoops. There we are. Good. Yeah. So just to conclude what we've seen so far. So the native UI story for Kotlin Multiplatform works well. In fact, it works very well. And we had lots of fun just building this little demo. So I actually learned Swift UI whilst doing this, so feel free to critique some of the code that was there. So it was great fun putting this together, and I was able to learn Swift UI along the way. So you can fine tune which code you want to share in this particular use case. As we've been saying, the different layers of your application, you can decide which ones you want to go out and share. And there were questions. I noticed that people have been asking, and then other people have been answering the questions. Thank you so much. Thank you for doing our job for us. So could you use Compose Multiplatform for the whole user interface? Yes, you could. See the next webinar for details. And then, yes, very good. Yep. And then you have access to an ecosystem of multi-platform libraries. And again, you only need to use the ones that make sense and work for you and so on. People were asking there in the chat, which DI library? Personally, I have had good luck with Coin. I mean, that's the one I default to. Pamela, what about you?
I also like Coin, but we had a tweet not too long ago, and a lot of people were saying they just like manual dependency injection. So that's also an option.
Yeah, cool. So there's different options out there, and there's a lot more functionality still to come. So Fleet. So Fleet, the IDE is, as we've said, still in public preview, getting better all the time. The support in there for Kotlin Multiplatform is just going to improve. And for people who are following the use case that we're showing here, the iOS and Android use case, the ability to navigate both ways, refactor from one to the other, do debugging, stepping in from Swift to Kotlin and so on, that's going to be really, really useful. And then, for all the wonderful things that you can do with Compose Multiplatform, that's coming up in the next webinar, as we've said. So that's pretty much our show. Thank you very much indeed. Yeah. So there's the remaining webinars. My job here is done. Pamela will be returning to you. Yeah.
Next Thursday.
Yes, returning next Thursday. So cool. And so yeah, thank you very much indeed. Cool.
Yeah.
So in terms of remaining questions there was a question asked about HTTP cache. I think you partially answered it anyway, Pamela, but just to say, yes, that the Ktor client does have an HTTP cache plugin. I think in this particular case, we just wanted to use Ktor because we just wanted to show a multi-platform library and the mechanics of including it and so on. Hopefully this webinar has just given you a feel for how everything plugs together and how you can write the application. We wanted to get you in the position where you can go out now, clone the repo and just start playing, because our application is a demo, as these things always are. But hopefully you can dig into it and extend it and so on, and then go out and do one of your own as well. So brilliant. Thank you very much indeed.
Yeah, thanks. Is there any other questions that you want to answer, Garth? I have one. I've got my eye on one.
Okay, yeah, no worries. I noticed that Martin was doing a great job of answering them as we went along. So yeah, but
Thank you.
any that you have your eye on, go for it. Yeah.
Yeah. So there's a question, what's the status of a decent navigation library for Compose multi-platform? So have you tried Voyager? It looks pretty cool. I've tried it a couple of times in a few of my like sample apps. It looks pretty cool. You should go check it out. Then let's have a look. I did save a few of these. I saw that Martin answered the bouncy castle debate. Thank you for that, Martin. I don't see anything else there.
I'm a huge fan of Bouncy Castle. I remember the days when you had to take a business trip to the US just to download an implementation of the Java cryptography sections, you know.
Okay, I think that's it that I can see now. But folks, please go check out the repo. We'd like to hear you actually like running remember to get your API key, running the code, looking through the slides. Please tweet at us. We'd like to hear from you and to hear what your latest adventures in Kotlin Multiplatform have been.
Absolutely. Thank you, folks.
Thank you, folks. Bye.